Hey there, HackerFrogs! This is the first workshop in our Intro to Web Exploitation course. Before we start, let's introduce the learning materials we'll be working through in the course. The CTF game we'll be playing to learn basic web exploitation skills is called Natas, which is hosted on the Overthewire CTF network. The Overthewire network hosts several different CTF games. The Natas CTF game is made up of many levels of increasing difficulty. The initial levels cover the target web exploitation techniques for this workshop. To learn about the Natas CTF rules, let's navigate to the following URL: https://overthewire.org/wargames/Natas. Let's look at the information on this webpage. Each level of the Natas CTF is located at a specific URL, wherein the only difference between the URLs are the numbers, which correspond to the level of the CTF. Each level's webpage is password protected, with the name Natas and the level as the username, and the flag obtained in the previous level as the password. Specifically, the username and password for Natas level 0 is Natas0 and Natas0. In each level of the game, the objective is to use web exploitation techniques to obtain the level's flag, which is the password for the next level of the game. If, as part of a web exploit, we are able to directly access the web server, the passwords for each level are located on the server in the /etc/nataswebpass/natasx file path, where X is the desired level number. So with all of this information in mind, let's start the first level of the Natas CTF game, level 0. A login window appears, so we provide it with the credentials we obtained from the previous page. Natas0 as the username, and Natas0 as the password. The level's landing page tells us that we can find the password for the next level on this page. But how? The first place we can look for clues in any web exploitation challenge is the web page's HTTP source, which we can access by right-clicking on the page, then selecting View Page Source from the options. We're using Google Chrome as our web browser in this demonstration, but the process should be fairly similar on any other web browser software. The browser displays the HTML source code for the web page, which are instructions that tell the web browser how to display the web page. More importantly for this exercise, however, is the fact that there are HTML comments included in the code, which are notes that can be left for development purposes, but will be ignored by the web browser that displays the web page. At the top of the source, on line 3, there's a comment which indicates that all of the code in the header portion of the source isn't relevant to completing the level, which means that all of the code until line 10 can be ignored. But on line 16, we see that the flag for the level, the password for Natas1, is here. We should copy the flag for the level with the Ctrl-C keyboard shortcut. Then create a text file to document what we found. We'll call the text file nataspass.txt. We can paste in the password for Natas1 with the Ctrl-V keyboard shortcut. Then we save the file. Now let's continue the game with Natas1. In our web browser, we adjust the address so that we navigate to Natas1 instead of Natas0. The username is Natas1, and the password we paste in from our text file. The level's landing page indicates that we can't right-click to access the page source. However, there's more than one way to access a web page's source in the browser. Let's open up another web browser tab, then search for an answer in a search engine. We'll plug in the name of our browser and HTML source keyboard shortcut. The results show us that there is a keyboard shortcut we can use. Control-U to access the HTML source. So we go back to the Natas 1 page and use the Control-U keyboard shortcut. And once again, we see that the flag for this level at the bottom of the source code. So we copy the password and document it in our text file. This is the end of Natas 1. But before we move on to the next level, let's learn about a particular web app exploit. Directory indexing is an insecure setting on websites that allows users to see file contents of web directories. Although it is quite rare to encounter this issue on modern websites, it is still very common to find it on older websites. If directory indexing is enabled, and a malicious user is able to discover different directory paths on the website, then sensitive files may be discovered, stolen, or otherwise abused. Now, in our web browser, let's go to Natas 2 using the password we recorded in our text file. The landing page indicates that there's nothing on this page, but if we look at the HTML source, we can see that something is a bit off. On line 15, we see that there's an image that's supposed to display on the page, but more importantly, the image is located in a web directory named Files. We can click on the file and it will bring us to the image, which is a single pixel on the screen. More importantly, we can test the website for directory indexing. We can try directly accessing the files directory by modifying the URL in the address bar. And because we're able to access this directory, we know that the application has directory indexing enabled, which lets us freely access the contents of different directories in the app, provided we know the directory names. Aside from the image file the HTML source was referencing, we see that there is a text file here. When we open the text file, we see that there are usernames and passwords listed within, including the username and password for the next level, Natas 3. So let's copy the password and paste it into our Natas Pass text file. We're finished with Natas 2. Before moving on to the next level, let's learn about another web app exploitation concept. Search engines, such as Google, Yahoo, DuckDuckGo, etc., use programs called robots to visit websites and map out their web pages. However, this may cause sensitive areas of websites to appear in search results. In order to prevent this, website administrators can add a file called Robots.txt to their website. This file specifies which directories and/or pages of the website are off-limits to search engine robot programs. Unfortunately, if malicious users know how to find the Robots.txt file, the contents of the file could potentially lead them to sensitive areas of the website. Now back to Natas Level 3. In the web page, we log into Natas Level 3 in the usual way. And seeing nothing particularly interesting on the landing page, we look at the HTML source. On line 15 of the source, we see a comment that talks about information leaks and how Google won't be able to find it. This is probably a reference to the Google search engine robot, so we can infer that there's a robots.txt file in the app that leads to a sensitive location. If we use the address bar to manually navigate to the robots.txt endpoint, we see that the file exists, and we also see that the file is configured to disallow robots from access to the secret directory, spelled in the manner where the number 3 replaces the letters E in secret. We can copy the name of this directory and paste it into the address bar to access it. And we see there's another users.txt file in this directory, like in the last level. And like in the last level, when we open the file, we can find this level's flag here. So we copy the password to our text file and we're finished with this level. That's the end of Natas Level 3. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. Before we proceed to the next level, let's cover another web app concept. Each time a web browser accesses a web page, the browser makes an HTTP request to the server that hosts the page. In each HTTP request, several headers and their values are passed along to the server to ensure that the browser and server can communicate properly. Here are some examples of HTTP headers and what info they provide to the web server. The host header supplies the website that is to be contacted. The user agent header specifies the type of web browser or other software that is making the request. The accept header specifies which type of data should be sent in response to the request. Please keep in mind that because HTTP headers can be modified by the user before being sent, this means that any values of HTTP headers could be spoofed, although default web browser behavior doesn't allow this. The HTTP referrer header contains the value of a complete or partial address of the web page that is making the request. This allows the web server to identify which web page users are visiting it from. The data from this header can be useful for analytics and logging, etc. However, some developers attempt to use the value of the referrer header as a type of security mechanism for which it was not designed. Now back to Natas 4. We log into the level in the usual manner. But on the landing page, we see that authorized users should only come from the Natas 5 URL. This implies that the web page is looking for a certain HTTP referrer header, which we can falsify, but not inside the web browser. The curl program is a command line interface app that is common to all major computer operating systems. The program allows for access to web pages from the CLI, but only returns text, such as HTML code. This app allows for the modification of various HTTP variables, which normal web browsers are not capable of unless modified. This is the syntax that the curl command will use to solve the Natas 4 challenge. Curl is the name of the command. The -v switch will provide verbose output. The -h argument allows us to provide an HTTP header. The -u argument allows credentials to be supplied along with the request. And the last argument in the command is the web page to which the web request will be sent. To use curl, we'll first need to open a command prompt window, which we can do in the following way. Click on the search field at the bottom of the desktop toolbar and type in CMD. Then click on the CMD app that appears in the results. We will use the following command with curl to access the Natas 4 website. Curl -v-H referrer http://natas.natas.labs.org/-u Natas 4 : At this point, you should copy the Natas 4 password, then paste it in using the Ctrl-Shift-V keyboard shortcut. After that, http://natas4.natas.labs.overthewire.org. When we run the command, the contents of the Natas 4 webpage are retrieved, but instead of using a web browser to do so, the curl program is used instead. Of course, since we aren't using a graphical interface to access the web page, we will only retrieve the web page's HTML source, At the end of the output, we see that we've been granted access, and the password for the next level is revealed. So we copy the password and copy it to our text file. That's the end of Natas 4. Before we start our last level of the Natas CTF for this workshop, let's look at one last web app concept. Another extremely common HTTP header is the cookie header, which is used to retain user settings or establish/maintain a user session on a website. For example, a website has a button on its user preferences page which sets the web page background color for the website. Once the color is selected, the web server will send a cookie to the web browser to be used anytime the website is visited, changing the web page's background colors to whatever is specified in the cookie. Similarly, when a user successfully logs into a website, the web server will send the web browser a cookie that identifies which user session is being used, and the browser will use that cookie each time the website is accessed. Any cookie that is used for user sessions has the potential for security abuse, so it is important that cookie values created for user sessions are not predictable at all. Now let's go back to the web browser to log into Natas Level 5. We log in the usual manner. But at the level's landing page, we see that we don't have access because we're not logged in. As we just went over, HTTP cookies are the typical method through which web app user sessions are established. In the web browser, there is usually a method to access the cookies used for any given website. For the Chrome browser, we can click on the triple dot button located at the top right, then navigate down to More Tools, and click on Developer Tools. From there, click on the Application tab. Then, under the Storage header on the left-hand side, open the Cookies tab. Then click on the Natas 5 URL. We see that there is a single cookie named Logged In, and that its value is set to 0. If we know a little bit about programming, we know that the number 0 is associated with the value false. We can set the logged in cookie value to true by doing the following. Double-click on the 0, then set the value to 1. Then hit the Enter key. That changes the value of the cookie. And when we reload the Natas 5 webpage, we are given the password for the next level. So we copy the password and paste it into our Natas password text file. That's the end of Natas Level 5. Let's review the web exploitation concepts we learned in today's workshop. Directory indexing is a vulnerability on websites that allows users to see the file contents of web directories, which can lead to sensitive data exposed to arbitrary website visitors. Robots.txt is a special file included on certain websites that indicates which files on the website can/cannot be indexed by search engines. It can be abused to point malicious users to sensitive parts of the website. The HTTP referrer header contains the value of a complete or partial address of the web page that is making the request. It's often used for analytics or logging. The HTTP referrer header is occasionally used by web app developers as a security mechanism, but this is not a good practice, as it was never intended to be used in such a way. HTTP cookies are commonly used as a security mechanism that allows users to maintain an authenticated user session on a website. In short, HTTP cookies allow users to log in to websites. But since cookie values can be modified by the user, proper care should be taken to ensure that valid cookie values are not predictable or easily guessed. In the next HackerFrogs AfterSchool web exploitation workshop, we'll continue learning web exploitation skills with Natas CTF. Looking for more study materials on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs.